Hey, this is Sam from Woodworking. This is the first half of a two-part tutorial series on how to make this modern coffee table that features the floating top. We cover a lot of ground in this video, including material breakdown, milling, cutting two types of bridle joints, shaping the stretchers to create the floating effect, and our first assembly. Quality woodworking plans are available for this piece, just check the description below. I'll note that a lot of woodworking techniques are demonstrated in these videos that can help you build the table successfully. That said, however you choose to complete this project, be sure to get professional in-person training to ensure safe execution for all your woodworking operations. Good luck and be safe.
So the first thing I like to do in any simple project like a small coffee table or a side table is to break down my rough cut lumber into more manageable sizes. From there, I'll move on to the milling and squaring of each component blank down to its final dimension. You can refer to the project plans for the exact dimensions each blank should be for each component. As you can see here, I've already broken down my rough cut lumber into more manageable sizes. I like to label each of the cut pieces before I mill, as I know each of them needs to be different dimensions, and then I don't want to have to recut or waste any timber in the milling process. So I've got two stretchers. This is going to be 4 legs, both of the rails, and here's the top, which we'll finish later. One thing that you should note when you do your rough board breakdown is that it's nice to have a little bit of material left over on the side in case you have any defects, especially when you're working with a project that requires a lot of precision, and it's likely we're going to run into mistakes. And when you go to your material supplier, don't try and get an exact yield, because the last thing you want to do in the middle of a project is run into the worst bottleneck possible of going back to the lumberyard.
The first stage in milling any piece of wood is to flatten one side of the board on the jointer. First, always check your joiner for square. In general, most boards have some curve to them. When choosing which side to flatten first, flip your board on your jointer until you notice the curve is pointing towards the ceiling. I'm going to reiterate the milling procedure more than once throughout this course because it's fundamental to good woodworking. When we mill our work pieces properly, it makes everything much easier and elevates the quality of our pieces. When bringing your boards over to your planer, make sure they're all oriented in the same direction. Ideally, the milled or flattened surfaces should be facing down so there's no confusion. Bring all of your boards down to correct thickness, and then you'll be ready to joint the first edge of your boards. When using the planer, always check your workpieces for your desired thickness and double check for square. Now that you've made 2 faces flat and parallel with each other on each workpiece, joint one of the rough edges on the jointer. Once this is done, you can bring your workpieces to final thickness. Depending on the size of your workpieces, you can bring them to final width on the table saw or run them through the planer again like me. Refer to the dimension drawings for the final thicknesses of each blank.
After I've milled and squared my rough cut timber, I like to square off one end on each piece using a crosscut sled, and then I'll cut them down to final dimensions using a stop just to make sure everything's identical in proportion. Take your time and be methodical through this process to make sure that you're cutting each component the right length. Mistakes do happen. Some of the components are similar in size, and you want to make sure that each component is cut to your intended length.
First thing I'm going to do is square off at least one end of each of the work pieces.
So to make a crosscut safely, you're going to want to create an auxiliary stop where the workpiece can exit freely so it doesn't get caught on the fence when you're making the cut.
This will be the final length of each of these parts, so double check with a tape measure between the table saw blade and your auxiliary stop that you have the desired lengths.
So we're done our milling, squaring, and sizing of the component blanks, and you can see I've got the 2 rails that run side to side, the stretchers that's going to be joined with these rails, and then I have 4 legs. The top is still rough cut lumber. I'm gonna break that down and mill it on another day. It's critical at this stage to make sure each component is sized perfectly and also perfectly square, because it's gonna make each stage moving forward a whole lot more straightforward and simple.
Now that the blanks are cut to size, we're going to cut the 2-degree angles on our legs and rails. To avoid mistakes, I recommend drawing the 2-degree angles on all of the workpieces. The angles on the legs should be in parallel, and the angles on the stretchers are not in parallel. Set the angle of your table saw blade to 2 degrees or 88 degrees. Set a stop up on your sled to trim the first angles on each of the table legs.
So now that I've cut the angles at one end of these legs, I'm going to cut the other end. As you can see, I'm using a stop, so they're all going to be cut to the exact same size. I still like to orient all my work pieces exactly the same so I can move through the operation as fluidly as possible. And of course, it also helps mitigate any mistakes. Now it's time to cut the same angle on the rails. I like to clamp them together like this securely in place, make sure they're down dead flat, and then I'll cut the first angle, and then I can move it up against a stop and then cut the other angle so they're identical in size. You're going to want to create an auxiliary stop where the workpiece can exit freely so it doesn't get caught on the fence when you're making the cut. So now that we've got the angles cut, we're going to remove the material on the stretchers, which is going to create the floating effect underneath the tabletop. To do this operation, you're going to use a drill press or a drill, as well as a 90-degree tenoning jig, which I've included plans for in this package. Cutting the shape into the stretchers is actually quite a straightforward process. What you're going to want to do is clamp both the stretchers together like this, and then take a look at the plans exactly where you need to drill the hole. There's going to be one there, and they're 2.25 inches in from each end.
Make sure to clamp your workpiece down and drill exactly on the seam line between the two workpieces.
So now that the holes have been drilled in the stretchers, you can take them apart, and we're going to move on to the last operation before cutting the joinery, and that is to remove this bit of material, which is going to create the final form and shape of the stretcher, and we'll do that on the table saw with the 90-degree tenoning jig. So what's key here is that the table saw blade is checked for square, and you want the height of the blade to run to the exact point of the bottom of the hole that was drilled, so it comes in perfectly tangent. Now, the depth that you want to cut, you're going to want to sneak up on that. Again, it needs to be perfectly tangent with the bottom of the drilled hole. So, I mean, you're going to be doing this 4 times. To get it perfectly, just go slowly the first time and sneak up on the cut until it's perfect, and then you can move through the rest of the cuts more fluidly.
With the saw turned off, continue to move the fence over, making passes until your cut is perfectly tangent with the drilled hole.
Now you can see after a few passes, I got that tangent with the drilled hole, the bottom of the drilled hole, and now I can move on to making the exact same cut on the rest of the ends. So we're ready to move on to the joinery for the leg, where the legs meet the rails, and that's going to be a bridle joint. We're going to use a 2-degree angled tenoning jig on the table saw to complete that operation. A few things that are critical is that we're going to start by cutting the female part of the bridle joint, so the mortise. We're going to cut the outer limits of the mortise first. So we're going to do all the cuts on one side with the table saw blade first, and then we're going to do all the cuts on the other side in sequence. So 4 on one side and then 4 on the other side. That ensures that the width of the mortise is going to be identical between all parts. The reason we start with the mortise first is because we're going to match the tenon size to whatever we end up with here. In the dimension drawings, it does say it's supposed to be 0.5 inches wide, and that's what we're going to aim for. However, it's unlikely we're going to get it perfect. So from there, we'll adjust and make sure the tenon fits perfectly snug into this later. You're going to want to absolutely make sure that that cut is centered as possible. Also, the depth in the dimension drawing says it's 1.5 inches. The depth is actually going to be whatever exact height you milled the rails down to. If it's 1.5 inches, great, but just double check to make sure you're cutting the depth of the mortise to the same height as whatever you milled the rail to. You're definitely going to want to do a test run on some scrap material. In an ideal world, your test will be done on a piece of material that is the same dimensions as what you plan to work on. I've got my leg set up to be cut for the first mortise, the blade set on the inside of the marked measurements, and the height of the blade is going to be identical to the height of our rails. We're going to cut each side of the mortise all in sequence on each table leg. So we're going to cut the left side on the table leg one at a time, and then we're going to adjust our fence over to cut the right side, and we're going to do all of them in a row.
Continue to repeat the cuts on each leg. Be sure to turn off your table saw between cuts and that your workpiece is attached securely to the jig.
Now that we've got that one side of the mortise cut, it's time to do the same operation on the other side. We'll line it up with the inside of our measured mortise. And again, we'll repeat this process 4 times so each mortise is identical.
It's critical to be precise here to ensure the mortise is centered.
So our mortises are looking like this. Now the job gets a lot more simple and requires less precision. We're just going to do the same operation except remove this center material.
I know I didn't do it here, but I do recommend turning your table saw blade off between each pass.
So now that we've cut our mortises and our legs, it's time to cut the tenons. Now, it doesn't really matter that these tenons or these mortises aren't exactly 0.5 inches. What is important is that we get the tenon to be the exact same width as this. Now the depth of cut for the tenon needs to be identical to the thickness of the leg. It's actually not bad to just have it slightly longer, so then you can have a little bit of protrusion on the tenon. So we're going to follow the same strategy as before. We're going to cut one side of the outer limit of the tenon in sequence on each piece, and we're going to try and oversize it just slightly, and then we can sneak up on a perfect fit later.
Whenever you flip your workpiece around in the jig, make sure it's oriented correctly for your next cut.
Now we can cut the other side of the tenon on both the rails, and just make sure again it's just outside your marked dimensions, and then we can sneak up on it to a perfect fit after. So now that we've got our tenon centered and oversized, let's remove the material on the left and right side, and then we can dial in the precision fit into our mortise.
If there's any part of the project that you need to focus and take your time on, this is it. It's very important our joints are cut precisely. Make sure to slightly oversize your tenons on your first cuts. We will sneak up on a perfect fit after we've removed most of the material. I recommend attempting a perfect fitting tenon on a practice piece of material before cutting your actual work pieces.
So now that we've made our mortises and removed most of the material for our tenons, it's time to sneak up on a perfect fit. What's key here is to remove as little as possible at a time, and that when you remove paper thin bit from one side, you go do it identically on the other side. And the reason for doing this is because you don't want to shave off a bunch on one side, so it moves the tenon out of center.
The key here is to take ultra light passes. Check your joinery fit as you go along.
Now that I've removed some material from one side on both parts, it's time to do the same on the other side.
It's important to remove equal amounts of material off both sides of the tenon so the tenon remains centered.
So that part of the process is fairly tedious, as you're trying to remove such a small amount at a time, and also you're trying to do it methodically to remove equal amounts from each side of the tenon so it stays centered. But that said, you can get pretty good results. So now that the bridle joints are cut for where the rails meet the legs, we're going to do the bridle joints for where the stretchers meet the rails. I'm going to start by using the 90-degree tenoning jig to remove this bit of material on each end of the stretchers, and then we're going to use a cross-cut sled to remove this material on the top and bottom of the rail for where the stretcher meets the rail. Now your goal is to have this middle part here be the identical width of your cut you make on the stretchers. And to do that, you're going to want to make sure you understand what measurement you ended up with on the stretcher, and then come up just short of it. So this middle part is slightly oversized from what you got on the stretcher. And then from there, you can do a little post-processing off of the table saw with a chisel, a router plane, a shoulder plane, or a palm router to sneak up on a perfect fit. Another critical point of this is that when you make these two cuts, you're going to want to do them slightly more narrow than the width of the stretcher. And the reason for that is we can plane the stretcher down to come into a perfect snug piston fit in the joinery. The depth of cut on the stretcher should be identical to the height of the rail.
To be certain your joints will fit snug and tight, do a test run on some scrap material. It's best to try to replicate the process with identically sized blanks. Before moving your fence over to cut the other side of the same mortise, Flip the workpiece once and make the same cut on the opposite end. Repeat this process with the second stretcher. Move your fence over to cut the other side of the joint. Be sure to position the cut at an identical distance from the edge as the initial cut. Make sure to keep the blade inside your marked lines.
Now that I've made identical cuts on each of the stretchers, it's time to hog out the remaining material doing the same procedure. This is the end goal for this stretcher. Just repeat that process 4 times. So I know I want this section of the rail to be identical to this cut made in the end of the stretcher. And to do that, just line the stretcher up with the table saw blade and make sure it's just shy of being tangent. And from there, we know that this middle section is going to be slightly oversized, and we can do our post-processing to get a perfect fit. And once I've got the depth of cut I want, then I'm going to set up my stops so I can make repeated cuts on the outer extremities of the joint. So we'll do one side, cut the other side, flip the rail, cut one side, cut the other side, so we get identical joints. And then after that, we'll hog out the remaining material. We're going to use 2 stops. One's going to be held on the table saw fence, which is going to limit the outer extremity of the cut. And then the second is going to determine the width of cut, which is going to be referenced off the width of the stretcher. Now remember, we want it to be slightly more narrow than the width of the stretcher. So I've got this in place. I know right now that that's perfect in theory, but I know I can get it perfect if I undersize it. So what I'm going to do, I will take that out, I'll move it over. Doesn't need to be anything particular, maybe a 30-second. Hold that in place, and I'll just double check to make sure it doesn't fit in case it slid. So now we know that this is going to be slightly undersized, and we can plane this down so it comes in a perfect fit.
I decided to cut the joints on both rails at the same time just to be efficient. That said, I recommend doing them one at a time to ensure you can keep them tight to the stops on each pass. I know this isn't the perfect example of safety in the shop, but I do recommend always turning your saw blade off when not in use. Please notice I'm using very tall stops. The reason for this is that the end of these workpieces are angled. If the stop is shorter than the height of the rails, the stops won't work to make your intended cuts.
So now that the widths of the cuts have been made identically throughout the rails, it's time to hog out the remaining material like I've done here. This part's actually quite a bit more straightforward since our widths are already set. Just go back and forth on the table saw until you've removed all the material. You can do one at a time or you can do 2. I like to do 2 just for efficiency's sake. To do 2, clamp them together outside, and then just go back and forth until you've got the result you want. Now that the joinery is cut on the rails and the stretchers, we still need to get a perfect fit between the stretcher and the rail. So we're gonna plane the stretcher down so it fits in here perfectly.
The key to getting the rails to fit perfectly snug is to take as shallow passes as possible on your planer until you get a perfect fit. Do one rail at a time and test the fit as you go. We intended for this joint to be thicker than the mortise. This is because we can easily sneak up on a precision fit with hand tools. I'm using a shoulder plane, but a router plane, chisel, or palm router with a bottom-bearing flush trim bit will work as well to remove small amounts of material accurately. Do not sand this down. Before jumping into your glue up, it's a good time to sand your components. Make sure you don't sand where the joints will be glued. The glue up is done in 2 stages. First, we're going to glue the legs. Do a dry fit of the stretchers and the rails first. So for the glue up, we want even horizontal pressure on the bridle joints. And to do that, you're going to have to make 4 shims that counteract the angle of the legs. And you can see here, I've glued 2 pieces on each side to make a channel to go outside of the bridle's tenon, and then put some tape on so it doesn't adhere to the glue. Take your time at this stage and attach each of the shims with clamps and position them accurately. To get effective downward pressure across the rails, you'll have to make this simple platform out of 2x4s. The more rigid the material, the better. The clamps will reach under it and pull down on the rails. Be methodical in applying your adhesive with a brush to all the joinery. It's a good idea to tape the outside of your joints to allow for less cleanup once dry. Because this is a complicated glue up, I use West System epoxy, which has a 1-hour open time, allowing me to take things nice and slow. And just a friendly reminder, we're not gluing the rails to the stretchers right now. Though your joint should be nice and snug, they may slip during assembly due to the lubrication. Have some more clamps ready to secure them in place. I will note for the final assembly, I didn't use these quick clamps on these joints. I used F clamps and I made them really tight. This is where the clamping platform comes in handy. You can see how I'm using it to apply downward pressure on the rails with these F clamps. The final clamps run horizontally and are positioned on the shims attached earlier. This is a challenging glue up, so be sure to have all the necessary clamps ready and available. Also make sure you orient your clamps so the successive clamps can be used correctly. It's best to do a dry fit or mock assembly without glue before jumping into the actual final glue up. So as you can see, this is a quite challenging glue up. You're definitely going to want to make this kind of platform so you can get your clamps running vertically to get the downward pressure. I used West System epoxy just because it has a long open time and it makes it so it's not so stressful, and I have a little bit of time, a little bit of extra time to get the job done without having glue go tacky. If you do want to use glue, I'd recommend using Type-On number 3. It has a reasonably long open time as well. The West System is about 1 hour, so there's no stress there. You're going to want to make sure you have plenty of clamps available. The first thing you should start with is getting the shims clamped on with the legs, and then I would do a light clamp on each of the bridle joints just to hold them in place. The glue sometimes does have some lubrication. And then move on to getting the vertical clamps in, and then finally running the horizontal ones.